Well, hello there, Mr. O here. Today we're going to talk about Focus Topic 6. This is the last of the focus topics for spring of 2020. And today's topic is differential equations and slope fields. All right, so recently we did some review on differential equations, solving using separation of variables. We're going to do that again today and talk a little about slope fields because we haven't spent a lot of time on that in my course anyway. So let's look at the sheet here. Focus topic 6. Focus topic 6. Here we go. I'm going to give you go over a couple notes here. We'll look at one question from a previous AP test, and then I think you'll be good to go. Feeling pretty good about this. So, what students should be able to do? Students should be able to find a general solution of differential equations using the method of separation of variables. This is generally the biggest part, the most amount of points in this type of problem. So when you see this, I am confident. Now you can always go back and watch the video afterward, but I think you're going to have one of these on this spring's AP test. I don't know anything. I don't have an inside scoop, but I see this so often. I think it's a relevant and big enough topic that you'll see it. Maybe not. So separation of variables, you're going to have two questions this spring. I think one of them will include this separation of variable stuff. Anyway. This is the only method that's tested using separation variables. So you're all set there. Find a particular solution using an initial condition. So you got to find your constant of integration. You got to find out what that C is and put it as an equation. Initial value problem, IVP. So then it says determine the domain restrictions. Sometimes you have a step in the solving of the differential equation where to solve for y you need to square root both sides. Well, that square root gives you a positive and negative option on the other side of the equation. Your particular point that you're given will determine whether you need to have a negative or a positive. So square root of y squared is going to create a positive and a negative root. And to determine which it is, positive or negative, you need to look at your initial condition. So that will be helpful. All right, so understand the proposed solution of differential equation is a function. It's not a number, okay? So, so they might be asking something like that. Growth and decay problems, draw a slope field by hand. Okay, we're going to do one of these because we just haven't spent a lot of time on that. And then sketch a particular solution given a slope field. If I have a bunch of slope fields, and for example this one, and they say, if it's 0, 1, try to draw a solution through this, and it's an estimate, but you got to be relatively close. But you would use your slope. This is a slope field. You would use this to figure out where is this graph going to go through that point. It's got to go through this point, 0, 1 in this case. Now, we're not actually do that one, but that's the idea. All right. Interpret a slope field. What does it mean? What kind of graph do you have? Given the derivative, to analyze a function such as finding extreme values. All right, all that stuff's going to go. Sometimes there's overlap, especially in this year's exam. I imagine there's going to be a lot of overlap. All right, 5 points. The 5 points are now distributed in this way. Okay, so separation of variables generally is 5 points out of the 9. 1 point for separating the variables. 1 point each for finding the antiderivatives. So you take the antiderivative on both sides. All of a sudden, you've gotten 3 out of the 5 points if you've done that correctly. You write a plus C, get another point, and then 1 point, the answer point for the correct answer. This includes all the algebra, arithmetic, everything, all like that. So your 5 points, when you do this, hopefully it's going to be a-okay. I got a feeling it's going to be great. All right, we're going to look at question number 4 from the 2016 test. This is non-calculator, and so we're going to do this one together. Put this around so I got some paper around. All right, number 4. Here they give us a differential equation. dy dx equals y squared over x minus 1. It says on the axis provided, sketch a slope field. The given differential equation at the 6 points indicated. So I see 1, 2, 3, 4, 5, 6, and you would do this right on that page because they're going to have you draw those slopes. So all they want is the slopes through these 6 points. That's all they want. So you're going to plug in a 0, 0. You're going to plug into here and get the slope. So if I plug a 0 on the top and a 0 on the bottom, and you can write them all out if you like. I'm going to put them up here. dy dx at the point 0, 0 and I'll have 0 over negative 1, which is 0. So you need to make it very clear that that slope there is 0. And I would do this, I'll do it another time just so you can see it. dy dx at the point, let's go over here, 2, 0. Let's try one that's not so easy. How about 0, 1? All right, so 0 goes here. 1 goes here. So we get 1 over negative 1. So our slope is negative 1 here. And you'd want to make sure that the graders knew that you know what a negative 1 slope looks like. Is it going to be perfect? No. But if your line is going to go from here to here and straight through, then your line, just a little line, that's what a slope field is, just these little dashes, and that's a negative 1 slope. All right, let's try one more where we work it out by hand. So this is 0, 2. So 2 here becomes 4. And this is, the point is 0, 2. So we'll have a 4 on the top, and we'll have a negative 1 on the bottom, because 0 minus 1 is negative 1. And so at this point, 0, 2, you plug a 0 in for x, a 2 in for y, and we get a slope of negative 4. And negative 4 slope is very, because you're only going to go about a quarter of the way here. This is very steep. Okay. If I were working on this problem, I'm running out of space here, but I would make it very clear, all of my math. I would make it clear so they could see it. On these ones, this y still has is 0 coordinate, so that slope's going to be 0. This point here, 2, 1. 1 is my y, 2 is my x, so it'd be 1 over 1, wouldn't it? 2 goes in the bottom, that's a 1 on the bottom and a 1 on the top. And now we're going 2, 2. So now we get 4 on the top and 1 on the bottom. This is a positive 4 slope. Yep, 2 squared is 4. There you go. This is positive 4 now. Okay, that's your 6 points, your slope field for your 6 points. Part B. Let y equals f of x be a particular solution to the differential equation with the initial condition f of 2 equals 3, very important. Write an equation for the tangent line of the graph at this moment when x equals 2. You use your equation to estimate f of 2.1. Okay, so let's do this on a separate sheet here. All right, this is part B. And our question is, our differential equation is this. dy dx, it's up here, equals y squared over x minus 1. And we have other information. We have f of 2 equals 3. And we want to estimate what is f of 2.1. That's what the question is asking, what it approximately. So first of all, to write a tangent line, you need 2 pieces of information. You need a point and a slope. Any point on the line and then the slope. The slope will come from the derivative. So we plug in a 2 for the x and a 3 for the y. So dy dx at the point 2, 3. 2 goes in there, it becomes a 1. 3 in here is 9. 9 over 1. All right, and so if we have a slope and we have a point, this is our point, 2, 3. Now we can write our equation for our tangent line, right? We could use point slope form, y minus y1 equals m times x minus x1. All right, so we plug in our point here. It's y minus 3 equals 9 as our slope, and then x minus 2. This is the equation for our tangent line. And the last thing they want you to do is estimate this. So here's your equation for a tangent line, and you could leave it in point slope form. Now you're probably going to want to swap it out in a moment, but you get the idea. So here's how you do this next part. Should I switch it to color? Sometimes I wonder how well you can see this blue. All right, we plug in for x, we're going to plug in a 2.1. So we get y minus 3 equals 9 times, and if I put 2.1 in here, 2.1 minus 2 is 0.1. So we get y equals 0.9 plus 3. Y equals 3.9. So we would say f of 2.1 is approximately 3.9. Go back, and I always go back and check and make sure we got all the parts of the question. Part B. Let y equals f of x be a particular solution to the given differential equation with initial condition f of 2 equals 3. Write an equation for the tangent line to the graph when x equals 2. There's our tangent line equation. Use your equation to approximate 2.1. F of 2.1 is 3.9. And that was used. We used our tangent line. We plug in this x value into the tangent line. And we were able to figure out what the y would be. And that's our approximate. All right, now part C says find a particular solution of the given differential equation with initial condition f of 2 equals 3. So we got to separate the variables and integrate. Okay, so let's go ahead and do that. So our once again, our differential equation, this is part C, dy dx equals y squared over x minus 1. All right, so we're going to get 1 point just for separating the variables. So how do we do that? We want to take this y squared, put over here, and put the dx over here. Right, so like dividing by y squared and multiplying by the dx. And what we end up with is this. We end up with a 1 over y squared dy equals 1 over x minus 1 dx. So far, so good? That's 1 point right there. So we're already 20% of the way to getting all of these points. I would recognize this. Hopefully, you'd see this as y to the negative 2 and integrate appropriately. Some will, unfortunately, some will call this integral on the left. They'll say, I know this is natural log, just because they're so used to doing that. Ladies and gentlemen, that is not natural log. Natural log is only when the power in the denominator is 1. If it's y to the second, you're just going to raise the power by 1, goes up to negative 1, divide by negative 1. This becomes 1 negative 1 over y. Okay? You need a little bit of intermediate step. This is y to negative 2. So if we integrate, we get negative 1 over y, or negative 1, y to negative 1. Move that over a little bit. Sorry about that. Okay, so that's the left-hand side. The right-hand side is natural log because x minus 1, that's x to the first power, and it's in the denominator. So this is natural log. U substitution not required because if I made u equal to x minus 1, the derivative would just be 1, and so we would not have to worry about that. So this on the left side, on the right side, natural log x minus 1 plus c. Notice the absolute value. Now, we need to find out what c is, and we use our initial condition to find that out. Our initial condition is f of 2 equals 3. That's our initial condition. So we plug that in here. By the way, integrating, I did 1 point for separating the variables, 1 point for each of the antiderivatives. I already got 3 out of the 5 points. So now we plug in using the initial condition. The plus c gives us a point. We plug in, we figure out that 3 goes in for y and 2 goes in for x. So negative 1/3 equals natural log of 2 minus 1 plus c. Natural log of 1 is 0. So c equals negative 1/3. I'm going to write the equation. C is negative 1/3. So we write our equation. Negative 1 over y equals natural log x minus 1 minus a third. And I think this would give us full credit. I wonder if they want you to solve for y. If you did want to solve for y, you could do that. You could just have to flip this. All this would go in the denominator. So you could write something like multiplying by negative 1 and then flipping, and it would be something like this. Natural log x minus 1 minus 1/3. And it's too low for you to see. Good job to check how they wrote the answer. Yeah, actually they wrote the answer like this. 1 point for separation variables, 2 for the antiderivatives, 1 for the constant of integration, including the initial condition, and 1 point solves for y. Okay, good point. Yeah, so you definitely want to solve for y in the end there. Ladies and gentlemen, this is your separation variables, including, don't forget, your slope field. What else is included in this particular worksheet? Question from 2011, question number 5, non-calculator. You could try that one. 2014, question number 6 from 2014 is very similar to this type of problem. And then question number 6 from 2013 is another one of these types. So there it is. That's your last focus topic. We'll be doing some more review again in the near future. I wish you well. Have a wonderful day.